the main idea of the Anova is to define are different samples under the same condition, and are they under the same impact, under the same factors which change there and give them variances, the random outcomes, or all of them are in the same condition. So to understand this thing, how to work the Anova and this analysis of variance, really will make us very short some example, very easy example. So for example, we have 3 different groups of students, and all of them learn the same subject, but they have different teacher who instruct them in this subject. And for example, they were graded for their final exam. So we have 3 groups. Group 1, Group 2, and Group 3. And they were graded. We know then in our university there are different number of students in each group, so we have the same situation for our example. For example, they have grade 35, 40, 44, 43, and 29, for example. So here we have 5 students, and 1 equal 5. For example, the second group gives another one grades and 2 students, they have the same grade, and here we have and 2, 1, 2, 3, 4, 6 students, and the last one gives uh, the biggest one group. Grades for final exam. So we want to know if this result depends on teacher or not. So what is the main factor which drives the result of the grade of the student? And the very first idea here, we have to estimate how many students here. 4, 5, 6, 7, 8 students. We have to estimate the mean value, the mean of all sample here. I remind you that mean value we can calculate using this formula. G here over n. So here we have n1, x1 equal 35 plus 40 plus 44 plus 43 plus 29 over n1, for example. And the same thing we can do for n1 equal 5. Summation over 6, and the same thing about x3. Calculation through Excel, and here I have x1 equal 38.2. x2 equal mean of the third group is 37.625. So in this calculation, at the first glance, the second one teacher who treated the second group is deserved to be awarded because the average grade here, the mean, is 41, and the worst one is the second teacher, 37.6. So should they have bonuses, this one and their first one, and maybe we have to punish the third one teacher? To answer this question, we have to make analysis of variance. We have to calculate the variances, set of variances. Okay. And the very first thing here, we have to calculate the grand mean. Grand mean, I denote like a capital X. It's equal x1 times n1 plus x2 times n2 plus x3 times n3 and divided by n1 plus n3 and 2 plus n3, and it's equal x grand, a grand mean. It gives 38.2 times 5 plus 41 times 6 plus 37.625 times 8 and divided by 5 plus 6 plus 8. What do we have here? X grand equal is 38.842. Okay. You can notice that the grand mean is very close to both x1 and x3. Okay, so this is the formula for grand mean. We have 3 samples here. If we have 4 samples, we have here extra term and for divisor and extra term for the numerator of this formula. And after this we have to calculate variances. And now we have to calculate the variances. And now they have 3 natures. First one, error variances. We have error 1, 2, and error 3 squared. These variances, they based on the deviation from each observation in each groups from the mean value of the group, from groups mean based on deviations of observations of groups observations from groups means. Answer 1. Treatment deviation. It stems from deviations of groups means of groups observation of group means, yes, from grand means, from the grand means, from the grand mean. I want to underline them. So first one, second one, and the third one is square. I don't put it. T capitals here, square. It means the total variance, which based on all deviations of deviations of all observations from the grand mean. Okay. Look, the error variance, they show the impact of the internal factors within each group. So here sigma squared with index E1 shows factors which impact the within group differences between grades. It can derive from different ages, different abilities of each student, and different background. Maybe they have different syllabus at school. This one, variance indexed with t small, shows the impact on each result from different surrounding of each group. So maybe it can show the impact of the teaching of each different teacher for group 1, 2, 3. And the last one gives the total variance, which depends as well depends on some internal factors as well as these outside factor, which can derive from teaching methods and teaching approach. Now we are ready to calculate them. Direct formula. I didn't know, remind you of this one, the common year of this formula. But sometimes it's better to use the reduced formula, this one. So it's a matter of your taste. So I calculated using the basic formula here, using this formula, for example, for the first one, group sigma e squared equal, or error deviation is summation of etc squared over n minus this number x squared squared. For this formula, for this one, for the first group, it is 35 squared plus 40 squared plus 44 squared plus 43 squared plus 29 squared over 6 over 5 minus 38.2 squared, and it is, according to my calculation, I used Excel, and it is 30.96. Okay, it is the first one. The second one, I put one more formula. You have to write to the square 1, 2, 3 all these given elements, divide by 6 and take away 41 squared, 32 squared, all of them 6 numbers, and you have 8.33. And for the third one, you have 53. Point what? 53.7. Squared. So if you don't mind, I put them here. So it means that standard deviation 1 is standard deviation 5.56. Second one gives you 833, so standard deviation 2 equal 2.88, and the last one (53.7) deviation 3 equal 16.26. What does it mean? Look here, very careful. It means that, look, the range of variances here of the result for the first group, it's about 5. So most of the people, they have result between some mean value plus minus 5 point. Here just about 3 points, and the last one, it has 16 here. By the way, from this point of view, we can say that the second teacher is really good, because the second teacher has the best average result or mean result, 41, and the most narrow oscillation between all the grades of all the students. And the worst one is the third one. This very wide range of oscillation of the grades comes from 2 grades. 54 here, the highest one. It is a very outstanding result. And the worst one, 29. Okay. Now we can calculate the other one, the variances. Group 1, Group 2, Group 3, and we have N1, 5, 6, 8. I have x1, the mean of the first group. And error variance gives 30. And the last one. Okay. Now we have to calculate the total variance. Sigma squared total. We can put the square root of total minus 6. We calculated, I didn't put the total x equal, the grand mean was here 30, 30, 30, 38, 8, 84, 38, 84. So here, the first one term you can calculate as a summation of all outcomes through all groups and divide by total number of observation. And you have, so we have here 5 plus 6 plus 8, and here we have summation across all groups. We have 35 squared plus and from the second one group all of the elements, and from the last one 32 squared. So we have here 19 terms, and this value is 1544.316. And if you put here this number into formula for total variance, we have here 115.44.316 minus 38.84 squared, and you have the total variance 0. Not so bad. I'm sorry. I'm sorry. I have here 5373. 5373. Okay. So the total variance is 35.30. You use this formula. Mhm. So you don't mind, I want to put here equality 3560. And the last one thing here, we have to calculate the variance of the treatment variance. The treatment variance is, I use, here it is. As I said before, it's based on the deviation or the groups means, and the grand mean. So you can calculate n1 times x minus x grand squared plus n2 minus and n3 squared over n1 plus n2 plus n3. And I have here n1 5 times x1 small 38.2 minus 38 84 squared plus 6 times 41 minus 38 84 plus 8 times 37.62 minus 38 squared, and we have here 5 plus 6 plus 8. So the treatment variance is, and it is according to my calculation, 2.202. Okay. Now we can analyze the most important sources of the influence on the grades of the students. Look, here we have error treatment, which goes from the internal sources which are within groups, and we have treatment variance, which goes from the differences between surroundings of the group, and they have the total variance. So the quotation, we have special correlation coefficients, and it's reading like eta. You can read it. Eta letter, Greek letter, equal square root of treatment variance, all the total variance, and it gives 2.2 over 35.6 square root. Now we have to calculate this coefficient, and it is, sorry, if I use calculator, you can calculate 0.248. So what does it mean, this correlation coefficient? We have to give some interpretation why it is 0.248. So if you don't mind the cleaning, I can clean this board and explain it. So we have here total variance equal 35.6, and the treatment variance 2.2. Okay, and now we have the correlation coefficient. Which is calculated square root of treatment variance over total variance. And to give an interpretation, we can say that as all correlation coefficient theta it belongs to the interval from the 0 to 1, and usually we say that if eta is less than 0.2, we have very no correlation. Eta more or equal 0.243, weak correlation. Eta 0.5, 0.7 maybe even, I don't know, more than 0.35. A moderate correlation. And if eta more than equal 0.7, strong correlation. For our particular situation, we got eta equal. For our particular situation, we got eta equal 0.248. It means that here the grades of students, they don't depend strongly from teaching, and their grades, most of them, so all of these three teachers, the teaching approach or method, they are more or less equal. and result of their student work depends on other factors, from their work, from their skills, how do they work. If you get number at or more, for example 0.35 or 0.7, it will mean that their result, their grade, depends on teaching or other surrounding factors. As a bottom line of this one part, I'll give you here all formulas to work on Anova, and and I want to make some conclusion. For example, you have a set of groups, a set of samples. Sample 1, sample 2, sample 3. And I don't know how many. You have some numbers here. So you have to calculate x1, x2, x3 means of groups. They are equal to summation of these x's divided by n number size of group sample. When you have to calculate their error variances, you can use the standard formula for the first one thing here. The second one, you have to calculate the grand mean, The third one thing, you have to calculate the treatment variance. A treatment variance. To calculate it, you have to make and 1 times and so you have to add all deviations for group means from grand mean and summation of all here. The fourth one step, you have to calculate the total variance, and it is summation of squared it depends on number of groups. And the first one, correlation coefficients, a correlation coefficient eta equal treatment variance over total variance. And you have to give an interpretation. If eta less than 0.2, no correlation, no outstanding factors. So here you have the layout of the Anova analysis and a guidance or roadmap. So if you have n number of samples, you have to calculate the sample means, their deviation within each of group, like error deviation. Then you have to calculate grand mean. You can use this formula. And you have to calculate two extra variance. A treatment variance that gives you deviation of the samples means from the grand mean, and total deviation, which gives you all deviations of all observations from the grand mean. And the last one step, you have to calculate the correlation coefficients between treatment variance and total variance. These coefficients shows you the contribution of all factors, the total variance, and contributions of the factors which work only within each of groups, because of teaching, because of something else. And if it is less than 0.2, you can say that all of these samples, all of these groups, they are under the same outside factors. There is no very specialities or peculiarities within each of group. Okay, see you later.